Hi, welcome back to the channel. In today's lesson, we'll see how to treat resistors in series and in parallel, especially when they are combined together in one circuit. In our last lessons, we saw how to treat resistors in series and in parallel. At the end of this lesson, I will leave you with a take-home example which you can solve on your own. That said, let's get started. For this series arrangement shown below, we should find the supply current. Now let's label the circuit. Let's tag this as this is our current. Now this is our first resistor. Let's tag it as R1. Let's tag this as R2, R3, and let's tag this as what? R4. Now if you look at the arrangement of this circuit, you have both series and parallel resistors. But the first is we should find the supply current. Then we need the total resistance in this circuit. Now my total resistance in this circuit, RT, will come from the series circuit R1 plus R2 and R3 are in parallel plus R4. So the first thing we'll do is to find R2 and R3. Now R2 and R3 in parallel will come from R2 times R3 over R2 plus R3. I explained this in our last lesson where we treated parallel resistors. In case you missed that lesson, please do not hesitate to check the description. I'll place a link to it. And for our series lesson, I'll also place a link to it at the end screen. Now, to ensure you get our lessons anytime we create them, please do not hesitate to hit the subscribe button. I'll be glad you hit the subscribe button. Subscribe to our channel. That way, you'll be telling us you love what we're doing. Now, so that R2 now, in parallel with R3, will be the same thing as 6 times 2 over 6 plus 2. Will be equals to 12 over 8. 4 in 8 will be the same thing as 2, and 4 in 12 is 3. That's same thing as 3 over 2. So that the cumulative resistance of R2 and R3 is the same thing as 1.5 ohms. Now, if the cumulative resistance of R2 and R3 is 1.5 ohms, then my RT now can be equals to R1 is 2.5 plus 1.5 plus R4 is 4 ohms. Now 2.5 plus 1.5 plus 4, that's the same thing as 8 ohms. Now if my cumulative resistance is 8 ohms, then my I, which is equals to voltage over resistance, will be the same thing as 200 over 8. 4 here is 2. 4 in 200, that's 50. And 2 here is 1. 2 in 50, that's the same thing as 25 amps. That means my total current supplied is 25 amps. Now the next thing we have to find is the current in each of the resistance. Now for the current in each of the resistance, you note that the current in R1 is the same current I that flows through it. So current in resistance R1, let's denote it as I in R1. That's the same thing as 25 amps. And this is equals to the same current that flows through resistance R4. Now that's the same thing in R4. Now the current that flows, let's find the current that flows through R2 and R3. They are resistors in parallel, so their cumulative voltage is the same. Now if that happens, remember we said that the R2 and R3 is the same thing as 1.5. So that we said R2 in parallel with R3, we said that cumulative resistance is 1.5 ohms. So that their voltage V will be the same thing as IR, which is the same thing as 1.5 times 25. That's equals to 37.5 volts. Now now we can now find for each of the resistance across the 6 ohm resistance, I across that 6 ohm resistance, let me put 6 in bracket, that will be the same thing as 37.5 over 6. That's equals to 6.25 amperes. And I across the 2 ohm resistance, that will be the same thing as 37.5 over 2. 37.5 divided by 2. That will be the same thing as 18.75 amps. So with this, we've defined each of the current across each of the resistance. Now the question still wants us to find the potential difference across each of the resistance. Now it's very easy. Now across the first resistance, we saw that the first resistance R1 is equals to 2.5, and the I that was flowing through it, let's call that I1, was 25 amps. So that the voltage will be equals to IR will be equals to 2.5 times 25, which is equals to 62.5 volts. Now for R2 is given as 6 ohms, and the current that flowed through R2, let's call that I2, is the same thing as, that's the current in the 6 is 6.25, that's 6.25, so that the voltage across R2 will be the same thing as 6.25 times 6. That's 6 times 6.25. That's equals to 37.5 volts. Now for R3 is given as 2 ohms, and I that flowed through R3 is given as, let's check that out please, 18.75. 18.75, so that the voltage across R3 will now be equals to 2 times 18.75, which will be the same thing as 18.75 times 2. That's equals to still 37.5. Now you can see that this confirms voltages across parallel resistors. Both of them have the same voltage. Now, and for the final one is 4 ohms, and the current that flows through it is 25 amps. So that on that note, that's I4, that's 25 amps, and R4, that's 4 ohms. So that V across it will be equals to 4 times 25, which is same thing as 100 volts. Now the good thing is, if you sum everything together, you should come back to, 200 ohms, 200 volts. Because the voltage across this is 37.5, the voltage across this is 2.5. Let's sum it together. That's my total voltage should be the same thing as 100 plus 62.5 plus 37.5. This should give you 200 volts. Now, that confirms the characteristics of resistors in. Like I did promise, I will leave you with a take-home example. I'll be glad if you share your results with us via the comment section. And our next lesson, this will be our anchor work. So here is a take-home example. You can solve this on your own and share your results with us in the comment section. Thank you for staying with us, and to ensure you receive our next lesson, please do not hesitate to hit the subscribe button. That way you'll be telling us you love what we're doing, and tell YouTube you love what we're doing. Thank you, and see you in the next lesson.